Today's lesson is over a review of distance and midpoint. So we're going to be finding the distance between 2 points. We're also going to be finding the midpoint between 2 points. And we're also going to do a little review of completing the square. So let's first talk about the distance formula. You may recall this from geometry. The distance formula is a formula used to determine the distance between 2 points. And so this is just how we fancy schmancy write. We have an x value and a y value in one ordered pair and another x value and another y value, which is why we say x2, y2, in another ordered pair. And here's our distance formula that we are going to use. And this is, in a roundabout way, found using the Pythagorean theorem. We're essentially finding like the length of the hypotenuse of all these different right triangles. Okay, so you may recall that from geometry, but let's get started over this concept here. So questions 1 and 2 say, find the distance between each pair of points. And I'm going to scroll down so that we can see this distance formula. Okay, I'm going to take the square root. I'm going to subtract my x values, square them. And I'm going to subtract my y values, square those, find the sum of those, and then take the square root of it. So let's do number 1. The first thing I'm going to do is label my ordered pairs x1, y1, and x2, y2. And you don't have to do that, but I'm just doing that to show you, you can always label your ordered pairs. So, oops, I'm sorry about that. Now let's plug in these values into our formula, the distance being the square root of, we're going to subtract our x values. So 7 minus -5, 7 minus -5 squared plus 4 minus -1. So if I do 7 minus -5, I need to do 4 minus -1. So 4 minus -1, and then I'm going to square that. And remember, when we're subtracting a negative, that's the same thing as, adding a positive. You can always add the opposite. So now let's simplify this. 7 plus 5 is 12. So 12 squared, we're going to add that to 4 plus 1 is 5. 5 squared. Now let's simplify it further. 12 squared is 144, and 5 squared is 25. And now we're going to add 144 plus 25, and we're going to get 169. And when we take the square root of that, we get 13. So the square root of 169 is a perfect square. So this is not a non-perfect square root. It is a perfect square root, or a perfect square. So the distance between those 2 points is 13 units. Now let's move on to number 2. I'm going to use this same formula. I'm going to take the square root of, and you can label x1, y1, x2, y2 if that helps you. And now we're going to plug in our values. So I'm going to do 2 minus -8, and then I'm going to square it. Add that to 3 minus -3, and I'm going to square that. So now remember, you can always add the opposite, and a lot of times I'll end up, if I know that I'm subtracting a minus, I'll just go ahead and write a big old plus sign. You can just do that, or add the opposite, whatever you want to do. 8 plus 2 is 10, so we're going to simplify what's inside the parentheses. 3 plus 3 is 6, and we're going to square that. And now we're going to actually square each one of these. So 10 squared is 100. We're going to add that to 6 squared, which is 36. And when I add 100 plus 36, I get 136. So I'm going to be taking the square root of 136. Now, 136 is not a perfect square. So what we have to do here is simplify this non-perfect square root. So you've likely had some practice with that this year, but this is how I do this. If I'm taking the square root of 136, the biggest perfect square that goes into 136 is 4. Well, I'm going to write that as the square root of 4 times. 4 times what is 136? 4 times 34. So the square root of 4 times the square root of 134 is, or not 134, I'm sorry about that, just 34 is 136. Now the square root of 4 is a perfect square, and the square root of 4 is 2. So 2 times 34 is the square root of 34 is the same thing as the square root of 136. So I'm going to rewrite this as the distance for this particular problem between these 2 points is 2 root 34, or 2 square roots of 34, also known as 2 times the square root of 34. So let's move on to questions 3 and 4. Questions 3 and 4 are slightly different. It says find the value of P so that each pair of points is 20 units apart. And I'm going to change colors here just because I want to. So now we're looking for an X value right here. We're calling that P. It can be given any letter, right? That variable just represents a number that we don't know. And I'm going to call that value X1. There's Y1. There's X2. And there's Y2. And I know the distance is going to be 20. The distance has to be 20. So now I'm going to plug in these values into my formula. I'm going to plug in what I know. I'm going to leave what I don't know. I know that the distance is 20. The distance equals the square root of, I'm going to subtract my X values, square them, subtract my Y values, square them, and then I'm going to take the sum of those numbers. So what I need to do is 9 minus P, and then I'm going to square that. I'm going to add that to negative 10 minus 6. And then I'm going to square that. So now let's keep going here. 20 equals the square root of, what can we simplify here? Let's see, we can't simplify 9 minus P squared, but we can simplify negative 10 minus 6. What is that? That's negative 16. And I can square that. So now let's take it another step. 20 equals, how can we simplify this equation, or the expression on the right side of this equal sign? Well, we can't simplify 9 minus P squared, okay? But we can simplify negative 16 squared. That has a value of 256. So I can add 256. Okay, so my goal now is to unravel this equation so that I can find what the value of P is. Well, I need to do what's on the outside first, which means I need to get rid of this radical. So I need to square this side. Well, what I do to one side, I need to do to the other side. So now let's simplify this. 20 squared is 400. We have erased this radical, and we're left with 9 minus P squared, which is a term we can't really get to yet, plus 256. So now our goal is to slowly keep unraveling this equation. And so I need to subtract 256 from both sides. To remove it from over here, remember, what I do to the left, I have to do the right. What I do to the right, I have to do the left. And I get 144. So now I have 144 equals 9 minus P squared. Okay, and I'm going to change colors here again, because now we have a square, and we need to undo that exponent of 2. How do I undo that? I take the square root. What I do to one side, I have to do to the other side. And what's important right here is the square root of 144 is positive or negative 12 equals 9 minus P. Now some students may be asking, but whenever we took the square root up here, we didn't say positive or negative 13 or positive or negative 2 square roots of 34. Well, we're finding the distance, right? And distance is going to be positive. But here we're finding the value of P. We're undoing, we don't know what that value is. It's not a distance, it's not time. So it doesn't need to be positive, and it can be positive or negative 12. So now what I need to do is I need to subtract 9. Remember, we're trying to get P all by itself, so we're going to subtract 9 from both sides. So what's tricky here, and I'm going to move right over here, is I have two options here. I have positive 12 minus 9, which is 3. And then I have negative 12 minus 9, which is negative 21. I'm going to write it like this, negative 21. 3 or negative 21 equals negative p. Negative 12 minus 9, I actually think I have that wrong. I think I did that wrong earlier. So 12 minus 9, which is 3, and then negative 12 minus 9, which is negative 21. And now I'm going to divide everything by negative 1, right? I got to find what p is, not what negative p is, and I get p equals negative 3 or positive 21. Or positive 21. Now, does that make sense? So I'm taking the opposite of what I had up here, right? If 3 or negative 21 equals negative p, then negative 3 or positive 21 equals positive p. Let's move on to another example. We're going to do the same thing over here. So over here, we're going to plug these values in again. We have a distance of 20, so I'm going to plug that in over here. D equals the square root of, this is x1, and this is y1, this is x2, and this is y2. So 12 minus negative 4. 12 minus negative 4 is the same thing as 12 plus 4. And then I'm going to square it. And now I'm remembering my distance formula. If you need to refer to that distance formula that I showed you at the beginning of the video or on your notes, you can refer to that. I'm just plugging in these values into that formula. And I'm going to add it to y2 minus y1, which is 6 minus p squared. And now we're going to undo this equation to find the value of p the same way we did number 3. So let's first simplify everything that we can on the right side of this equation. So 12 plus 4 is 16. So I know that this is 16 squared, and some of you might be going, okay, and I know 16 squared is 256. Okay, I'm going to go ahead and that's fine. I just like to show every step on my notes so that you know whenever you're doing your assignment, you can refer to your notes, say, what did I do here? And you have every step outlined. So now 20 equals, what can we simplify now? 16 squared is 256 plus 6 minus p squared. Okay, so now the goal is to get to that variable. So what I need to do is remove that radical. What do I do to do that? I'm going to square both sides. 20 squared is 400 equals, I've removed the radical, and I get 256 plus 6 minus p squared. And now this feels very similar to the one on the left, or number 3, because now I'm going to subtract 256 from both sides. And I'm left with 144 equals 6 minus p squared. So this is very similar to that. So if you have any questions from, what to do at this point, you can always refer to number 3 as well. So now I need to get rid of this exponent of a 2 right here. And how do I do that? I'm going to take the square root. What I do to one side, I have to do to the other, and I'm left with positive or negative 12 equals 6 minus p. So at this point, now I need to subtract 6 from both sides. So when I subtract 6 from both sides, I'm left with 2 choices. I can take 12 minus 6, which is 6, and I can do negative 12 minus 6, which is negative 18. Those values equal negative p, which means p equals negative 6 or positive 18, and those are my answers, negative 6 or positive 18. So let's move on to the next section of our notes, and this is finding the midpoint between 2 points. So I have 2 endpoints on a line. What's the middle point? Well, I'm going to use this formula. The midpoint formula is used to find the center point of a straight line with endpoints, this ordered pair, that ordered pair. So here's what we're going to do. The midpoint between any 2 points, I'm going to add up the x values, divide by 2. That's going to be my x coordinate. going to add the y values, divide by 2, and that's my y coordinate. And it's as simple as that. It's like I'm taking the average of those 2 points. Okay, and that's the middle, right? The average. So let's move on to 5 and 6. Find the midpoint of each line segment given its endpoints. So if you want, you can do your label, which I'll do on this one, and I won't do it on number 6. So the first thing I'm going to do, if I am finding the midpoint of the line that contains these 2 endpoints, I'm going to add up my x values. So that's 3 plus 13, and then I'm going to divide by 2. Then I can add up the y values, which is negative 10 plus negative 2, and I'm going to divide by 2 to find that y coordinate. So the midpoint would be 3 plus 13 is 16, then I'm going to divide by 2. Negative 10 plus negative 2 is negative 12, and then I'm going to divide by 2. So now let's write this down. The midpoint for this, 16 divided by 2 is 8. Negative 12 divided by 2 is negative 6. There is the middle point between these 2 endpoints. That's the very center. Let's move on to number 6. I'm going to do the same thing over here. I've got my ordered pair. I'm going to add up my x values, which is 7 plus negative 2, and then I'm going to divide by 2. I'm going to add up my y values, which is 15 plus 9, and then I'm going to divide by 2. 7 plus negative 2 is positive 5 over 2. 15 plus 9 is 24 over 2. So when I write this down, my ordered pair is, I can write 5 over 2. I can write 2.5. It's the same thing. And I promise you, your teacher knows the difference. That 5 over 2 is the same thing as 2.5. So I'm going to write 2.5. But I could have written 5.2. Just whatever you're feeling. And then 24 over 2 is just 12. And there's the midpoint of that line segment. And so now we're going to do a little review of completing the square, and all I want you to do to review the completing the square is write your answers in this form right here, which is a plus b squared equals c. And I've got this little reminder because a lot of students are like, what do I add to both sides? B over 2 squared. So if you recall, when I am completing the square, I need to write it in the form of x squared minus 14x, and then I'm going to be adding something to this side, and I'm going to move this constant to the right side. So I'm going to add 8 to the other side, but I'm going to be adding something to both sides. And I'll go ahead and put a plus sign here. I'm going to be adding something to both sides. What am I going to be adding to both sides to complete the square? I'm going to take this negative 14, which is b. I'm going to put it over 2, b over 2, and then I'm going to square it. That would be negative, that would be negative 7 squared, which is 49. So I'm going to be adding 49 to both sides. Now, why do I add it to both sides? So that my equation stays balanced. What I do to one side, I must do to the other side so that my equation stays balanced. But what you have effectively created here is a perfect square trinomial. So now my 2 numbers that multiply to 49 and add to negative 14, well, that's just going to be b over 2, which is just negative 7. So I'm going to write this as a binomial squared, which is x minus 7 squared equals, and then 8 plus 49 is 57. And that's all you have to do for this part, because all of these skills are very important in your conic sections unit. You're going to be using all of these skills in the various parts of this unit. So this completing the square, you're going to have to know when you're converting from general form to standard form for all your conic sections. So we're just taking some time to review this particular skill. So let's go on to number 8. Number 8, let me zoom in here. What I'm going to do is I'm going to rearrange this, and I'm going to move this negative 5x over to the left side. So 2x squared plus 5x equals, and then I'm going to move that constant to the right side. Okay. And now, you know, when you're completing the square, you need a leading coefficient of 1, which means I need to factor out this 2. When I factor out this 2 from the expression on the left side of the equal sign, I'm going to divide 2 out of every single term. So I'm left with x squared, right? Because 2x squared divided by 2 is just x squared. And then what does that middle term look like? Well, I'm just going to write it like this, 5 over 2x. I can just write it like that because half of 5 is 2.5, and that's the same thing as 5 over 2, which we talked about on a previous problem in our notes. And now when we talk about completing the square, if I complete the square on the left side of this equal sign, I'm going to be adding something to this to complete the square. And then whatever I add to that side, I need to add to the right side as well. So now let's think about what we're going to be adding. If we are adding b over 2 squared, well, b over 2 is 5 over 2 over 2. 5 over 2 over 2. So if I write that down, I'm going to write it down here, and then I'll erase it. That's 5 over 2 divided by 2 over 1, which I could rewrite as 5 over 2 times 1 over 2, which is 5 over 4. So b over 2 is actually 5 over 4. b over 2 is 5 over 4. And then I'm going to square that, and that would be b over 2 squared, which is 25 over 16. So I'm going to be adding 25 over 16 to both sides. Okay, so what happens here? I've got this 2 on the outside of my perfect square trinomial, which is fine. It's right there. And then I need to figure out how to take this perfect square trinomial right here and write it as a binomial squared. Well, that's just going to be x plus, because this is a plus right here, and it's just b over 2, which we said was 5 over 4 squared, equals, and now we've got 16 plus 25 over, oh wait, did I even factor out a 2? You know what I forgot to do? When I divided out a 2, you know what I didn't do? You know what I can do? I can divide out a 2. I'm sorry that I didn't do this. I can divide out a 2 from both sides here. So what that would make this look like is 8. And then what happens there, when I divide out that 2, this goes away as well. Okay? So I should probably have said that. When you divide out a 2, which in doing this, I don't have to write a 2 right here. I divided that 2 out of both sides. So you know what? Another way you can look at it is if I had this right here. Let's see, before I did my little perfect square trinomial and I added that b over 2 squared, I had the 2 here and the 16 here. Well, I can divide both sides by 2. That goes away, and this becomes 8. And now I don't have to write that 2 there. And that's a better way to do it. What I need to do is create a common denominator. So I need to multiply both the numerator and denominator of this fraction by 16. And 8 times 16 is 128 over 16 plus 25 over 16. And now I'm just going to add the numerators. And 128 plus 25 would be 153 over 16 equals x plus 5 over 4 squared. And that was a very challenging problem for completing the square, number 8. But that does conclude your notes over a review over distance, midpoint, and then a little review over completing the square. I hope it was helpful.